actually asked as part of the broadcast, we were like, you know what, I think it'll be really fun. And the overwhelming amount of people who wanted to record something for the crew was really heartwarming.
Yeah, you know, this is the first time in over half a century that we're sending people back to the moon, and everybody is excited about it. You know, kindergarten to congressmen and all over the world, everyone is ready for today and excited to see this launch.
And so here we are again, still inside Orion with the closeout team, putting some final touches on, it looks like Victor's configuration there. Again, making sure that his harness is set and that he's connected to cooling, he's connected to communications, and he's connected to any other umbilicals that he needs to be connected to for Orion. Again, we are sharing so much information with you, and we hope you find it educational and fun. But we do know you guys still have some questions, so why don't we take another one now?
Tell us what the moon is like!
So cute. That wasn't a question. That was a demand. Nicole, you tell her what the moon is like.
Oh, man, that was so cute. Oh, man, the moon is really cool, right? So it's a lot of like gray and white and kind of shades of gray. It is something that doesn't have wind or rain or rivers or an atmosphere. And so we like to say it's Christina said it earlier, it's the witness plate to the universe. And, you know, it has all these impact craters because it's not protected. Things hit it all the time. Meteoroids, asteroids, all sorts of things hit the moon and create these impact craters. That's part of what we want to go and look at and learn about on the moon. Can tell us a lot about the age of the universe and the age of the moon. You know, it's 4.5 billion years old, and we can learn a lot from just looking at the regolith or the dirt that is on the moon.
Well, thank you for that question, and thank you for that answer. She was cuter, Nicole.
I agree.
And then earlier today, we wanted to ask you, what do you want to know about living in Orion? And we told you to pick between what the crew eats, how they sleep, how they fly the vehicle, and how free time is spent. And the winner, most of you wanted to know how to fly the vehicle. And we are going to be doing that.
Yes, we are. You know, that's a great question, and actually part of what we're going to go do. So the rocket is fairly automated, right? There's a countdown, and the whole system knows when it needs to ignite the engines. But we are going to do some manual piloting throughout this mission. Once they launch and they separate from the ICPS, they're actually going to do a rendezvous and proximity operations demonstration. So what does that mean? They're going to take that portion of the rocket and they're going to try to fly closely to it. And so they will actually take manual control of the Orion spacecraft and try to get nice and close to the other portion of the rocket that had just separated. And so you can see actually a little bit in the view that you have right now. So on for Reed, the left-hand person, his right hand, there's a kind of a joystick, if you will, on the right side, and then on the left side there's something similar. And so they've got, you know, translational and rotational hand controllers in order to command the rocket in different axes.
Yeah, it's really exciting. I mean, Victor said it himself, like one thing that he's really looking forward to is piloting Orion manually. So we'll get to see that during our continuous coverage. Again, we are covering this entire mission. We started with tanking, and we will go all the way through splashdown, so you will see what Nicole was just talking about, that proximity ops demonstration, where the crew will pilot Orion manually. And so, speaking of their 10-day mission, why don't we take a closer look at the crew's home away from home for the next 10 days. Here's Megan Carter again from the KSC Visitor Complex.
All right, thanks, Megan. Yeah, it's getting real out there, so I am going to bring you back to the moon board so I can show you just a few things about the Orion. Obviously, it is going to be very compact, sitting up there on top of the SLS rocket. Very compact, like I mentioned, over 355,000 pieces. So let me show you a couple key components, starting with these three fairing panels right there. When the rocket blasts off, obviously it is going to get very fast.
MS1,
It's going to get
NTD on
hot
Orion Earth 1 for
and
comm check.
windy. And so we have these 3 fairing panels in place to help protect our astronauts. I am also going to take you into a little bit closer look and talk about the LAS, or the Launch Abort System. This is the one piece that is going to be in place to protect the astronauts should something happen to go wrong in the first few minutes of launch. They can actually hit those abort motors, and these can activate within milliseconds, basically faster than you can easily blink, and that is going to pull the capsule away from any danger. Now, obviously, we hope that those are not here, and if that is the case, then about 3.5 minutes into flight, the LAS and those fairing panels will actually activate and jettison away. They'll fall away from the rocket, because at that point, the crew can actually abort the spacecraft safely by themselves. Now, we've talked a lot about the crew capsule right here. This is where they are going to spend the duration of their flight. We're going to talk a lot more about that one in just a little bit. But for now, let me jump down here to the service module. This is the one, we're going to think of this as the powerhouse for the spacecraft. It's pretty much going to provide them with almost everything that they need for the entire mission. Temperature control, removing the carbon dioxide, providing them with oxygen, so much more. You can also do course corrections and things like that. So super quick breakdown, but as you can see, all of these components together are going to make the spacecraft one that is built not just to fly, but to protect, sustain, and bring those astronauts home. All right, lots more to come, but let's see where we are with the crew. Back over to you, Megan.
Hey, thanks so much, Megan. A lot of useful information there. And we did want to point out that you did hear over
and PLT, NTD on Orion Earth 1 for comm check.
NTD PLT, I have you loud and clear on OE1.
And I have you the same. Welcome aboard.
And so, again, we are now hearing mission audio loops, specifically the Orion to Earth 1 loop, the communication channel for the crew. Successful comm checks by both Victor and Christina.
CDR, OTC Orion Earth 1.
CDR.
Yes, sir. Configure ARS to suit mode per EPROC 10.1.1. Crew ingress and vehicle pre-launch config. Step 1.
10.1.1 crew ingress and vehicle pre-launch config. Step 1. Going in work now.
And so see, now we are privy to some of the countdown procedures that the team is asking for the crew to do.
Yeah, so they're going to work through some of these procedures and finish the ingress portion, as you heard in that procedure. So this is where the crew's going to start building their nest, if you will, running some procedures, getting the capsule ready for humans to be on board.
And now look at the clock, 3 hours, 30 minutes and counting until the opening of our 2-hour launch window, and we are pretty good on time. We are as we are expecting in terms of when ingress will be wrapping up soon. And so now let's bring Gary Jordan, again, our commentator inside of Mission Control at Houston. Gary, let's check in with you about mission preparations.
Hey, Megan, thank you. Yes, we're following along here in Mission Control Houston.
OTC copies.
And we'll stand by for those comm checks. And again, we're waiting for those comm checks. We did confirm from our IVA officer here in Mission Control Houston that all 4 suits have plugged in umbilicals.
And CDR, NTD.
Go ahead, NTD.
Yeah, Reed, we're ready to proceed with the voice checks if you and everyone else is.
NTD, integrity crew is ready for voice checks.
I copy that. And integrity for the entire crew, comm check on Orion to Earth 1.
CDR. PLT.
MS1.
MS2.
Good comm check by all. NTD moving to Orion to Earth 2.
CDR. PLT.
MS1.
MS2.
Integrity Houston on Orion to Earth 1. Voice check for the entire crew.
CDR. PLT.
MS1.
MS2.
Houston has all 4 crew loud and clear on OE1. Stand by for 2.
Your initial word was broken.
MS1.
MS2.
4 crew loud and clear on OE2. We'll use 1 for the default. Houston out.
And CDR, NTD?
CDR.
Yeah, we're going to go ahead and we're going to clear a couple of those messages on your screen here. Just want to give you a heads up that you'll see that.
Copy all.
CDR, OTC, Orion to Earth 1.
CDR.
Yes, sir. Perform crew suit leak checks per 10.1.1. Crew ingress and vehicle pre-launch config, steps 2 through 4. Annunciation of LCC O-ARS-001 will occur.
10.1.1 crew ingress and vehicle pre-launch config steps 2 through 4 going in work now.
This is Mission Control Houston. We are following along as the 4 crew members of Artemis II work through their voice checks, then the umbilical connections and various pathways to get communications from all of the...
refresh on your screen.
CDR.
Yes, sir. We're going to look to do a quick refresh on your screen if you guys are okay with that.
Okay, firm, just let us know when we can continue in 10.1.1. We'll go hands off.
.1.1 referring to the procedures that they have through the various phases of ingress and some of the checkouts needed to prepare for today's launch. Here in Mission Control Houston, the IVA or Intravehicular Activity Officer will be confirming the leak check status and watching as the suits pressurize to once again confirm that the suits are in a good configuration ahead of launch. Of course, for the teams here in Houston, launch is just the beginning. The first flight day is jam-packed with activities. Shortly after main engine cutoff, Integrity will enter into a coast phase while still attached to the Interim Cryogenic Propulsion Stage, or ICPS, and prepare to deploy the solar arrays. With power being generated, Integrity prepares...
Go ahead, NTD.
With that refresh, and you got to go to proceed with your 10.1.1.
Picking up 10.1.1, step 2.3 through 4.
picking up the procedures, the crew again working through the various steps to prepare for launch, standing by for suit. This is Mission Control Houston with visors closed. The pressurization tests can commence. We'll stand by for word of a good leak check on all 4 of the crew member suits for the Artemis II mission. Again, this is the very beginning of a very busy flight day for our 4 crew members. After launch, they have a series of burns to prepare for. The first major burn being the perigee raise maneuver that allows them to continue in low Earth orbit, and the next being the apogee raise burn that puts them in a high Earth orbit. This is an orbit that takes them around the Earth for nearly a day, 23.5 hours to be precise, and allows the teams, including the astronauts and the flight control teams, to check out critical systems ahead of committing to the next day's translunar injection. But before they even call it a day, Integrity will separate from the ICPS, and the crew will command the Orion capsule to separate from the ICPS and turn around and approach the upper stage, but not dock. This is to test Orion's in-space maneuvering capabilities and provide further confidence in docking to another lunar space vehicle like the Human Landing System that will be part of the Artemis III mission ahead of future moon landings. These are just a few of the highlights of the may be able to see from this view the suits themselves inflating. This is again a pressure check, verifying that the suits are leak-free ahead of the Ascent portion of today's flight. How you see the crew now with visors down will be the configuration of their Ascent all the way through core stage separation, about a little more than 8 minutes after booster ignition. All right, here in Mission Control Houston, we are continuing to follow along, standing by for confirmation of good leak checks. In the meantime, there are no showstoppers here in Mission Control Houston, and we continue to monitor the countdown to launch. Megan, we'll send it back to you over at the Space Coast.
Hey, Gary, thank you so much. Yeah, as we wait for confirmation of a successful leak check for all 4 astronauts, why don't we go back to Daryl, again, who has been following along with the launch countdown as we inch closer to the opening of our 2-hour launch window.
All right, thank you, Megan. And yes, getting some good communication. It's great to hear from the crew inside, even though it is as simple as a comm check. It's really good to hear their voices as they move through those various comm checks and then get ready for their suit leak checks. Fantastic views inside Orion that you're looking at now. Give you an update on the weather outside. We're still 80% go for our 2-hour launch window, which starts at 6:24 p.m. Eastern Time and closes at 8:24 p.m. Eastern Time. That's the good news. The bad news is that we've got some rain showers that are starting to head in. Looks like it may miss the pad. Wouldn't matter if it rained on it or not, though. It's received some rain earlier today. Water isn't going to hurt anything out there at this point. But the rest of the area might be getting a little bit wet, which may include the hostess, so keep an eye out for that. As we're watching with the astronauts inside the Orion Integrity spacecraft, you'll be hearing more and more from them, especially Christina Cook, who is mission specialist number 1. She not only is going to be making history.
All crew, visors open, suit loop leak check complete.
OTC.
Okay, there you heard the suit leak check complete. They check those suits for leaks in the astronaut crew quarters. They check them again inside the spacecraft. As you can see, the closeout crew, our astronaut support person moving around, turned off the camera, and so now we're looking from outside the Orion spacecraft, looking towards, oh no, let's see, get oriented here. Well, there we go. Back inside, we've got the view. But basically what I was saying about Christina Cook is that she will have the role of reading.
CM is ready for closeout, performing video sweep using drag-on camera.
OTC.
She will have the role of reading out a pressure reading that tells the team that
And CDR or NTD?
Go ahead, NTD.
Yeah, we're going to do another cleanup on those suit leak check messages that we got from since we're done with that now.
Integrity copies.
Yeah.
and that's communication going between Orion Commander Reed Wiseman and NASA Test Director Jeff Spaulding. As I was saying, Christina Cook will be reading measurements from the counterbalance assist arm, so you're going to hear her be asked by the NASA Test Director to read that. That CBA, counterbalance assist arm, it's mechanically latched by the closeout crew using tools, but there's a hydraulic assist. It's pneumatically opened and closed rather with a pressure assist that helps open it up. Not only that hatch, but also the last hatch. There's two hatches there that we'll see that will be closed, but this is in case of an emergency out there at the pad. If the crew for some reason needed to exit quickly, then they would exit the spacecraft by pulling that lever, which would open both hatches. Those hatches are heavy. The Orion hatch is hundreds of pounds.
HHD cameras 1 and 2 both set to record.
OTC copies.
And just an update on the launch countdown, continuing to monitor the team's communications here in Firing Room 1. Everything going really smoothly so far. We don't have any significant open constraints to launch at this time, so we continue counting down. And for now, we'll send it back to the hostess with Megan and Nicole.
Thank you so much, Daryl. And so we heard some of the communications over Orion to Earth 1, and it sounds like we are now moving into the hatch prep and closure phase. We will now start to see the closeout crew getting out of Orion soon so that they can start getting ready to, again, close up Orion, close the two hatches, and then get out of the pad.
Yeah, the closeout team will take the hatch seals off, and they'll inspect the seals, make sure everything's ready to go, and then do a few last-minute configurations before they close that hatch. And then, like Daryl talked about, then Christina will have a role in looking at the CBA there. So.
Yeah, you might have heard them say over the loops again that drag-on camera. So basically, it's a camera that they can move around, and you might have seen it in a couple of our shots already. But they will take that camera and literally go and inspect the seal that, there's two seals actually, two seals that go around the entire area of the hatch, just to make sure that everything looks good, and that camera feed is being directly shown to NASA teams who need to monitor that.
Yeah, they want to make sure there's not a single hair or piece of dust on those, make sure that there's no damage and everything's ready to go, so that the seal, they will do a leak check on this hatch seal as well. Make sure it passes.
Yeah, and we'll know they're doing that because we will actually see one of the closeout crew members with a hand pump, and they will pressurize, again, just the seals, and they have to see if it will hold pressure for just a minute. And if it does, then they will go ahead to pressurize the entire Orion spacecraft, and then that again is to make sure that the spacecraft is holding the right amount of pressure. And that one's a lot longer. It'll take them like 8 minutes. Like it takes time to pressurize it, then they have to hold pressure, and then it takes time to depressurize it.
Right, and they want to measure the difference in pressures at the beginning and end of that, and make sure that it holds the right amount of pressure, so that when they get to the vacuum of space, obviously the capsule holds its pressure.
Yep. Okay. Well, again, as we continue to watch operations that are happening at the pad inside of Orion, why don't we go over to Banana Creek? It's one of our viewing locations here at Kennedy Space Center. They will have a spectacular view, and we actually have NASA's Leah Martin there chatting with a big group of people surrounded by a lot of folks on bleachers there.
Hey Megan, yeah, tons of people out here today, thousands of people gathering at Banana Creek to enjoy NASA's next big mission and humanity's next great leap today. It's a gorgeous day, and I'm joined here actually by some people who are probably the only people on center who are a little bit more excited than me to see this rocket lift off. Where are you from and why are you here?
So we're from the University of Tennessee, Knoxville. We're a group of 7 aerospace senior engineering students traveling here with Josh Dobbs, former quarterback of the University of Tennessee, with his extraordinary Dobbs Foundation.
Now, you were actually telling me a little bit earlier, you're here local, you're from Orlando. What's it like being an aerospace engineer and then having the opportunity to come back here to the Space Coast and see this mission lift off today?
It is absolutely amazing. I feel like the little 9-year-old girl inside me is so excited. Like, I'm from around here. I grew up watching launches in my backyard, and so this seems like such a full circle happy moment for me.
Now, you are an aerospace engineer looking hopefully to join the workforce in the future. How does it feel to be here and see firsthand what that work does?
It's just so cool to see what I've been working for the last 4 years, and then 12 years before that, just actually be physically happening in front of me. It's something I never dreamed of as a kid.
And I'm actually joined here by the pastronaut himself, Mr. Josh Dobbs. Now, you have a history with NASA as well. You did an externship here. And how did that kind of play into your passion for aerospace and then the foundation that actually provided this opportunity for these students today?
100%. So I spent a month here around the Artemis I mission, which was a tremendous opportunity to learn about the space program and also what's next. And so to be back here for Artemis II, and unfortunately, Artemis 1 went in the middle of the season, so it's surreal to be here for Artemis 2. And with my foundation, like, the goal is to be able to take advantage of the opportunities that I've had and pass them along to the future of the industry, and give them the opportunity to see what all their hard work can accumulate into. So it's an honor to be here. We're really appreciative of all the engineers and all the hard work that's gone into this moment, and we're excited to watch history happen today.
Absolutely, and as a group, I think if you guys had one well wish for the team today, what would you say? I think we can all join together, maybe say go Artemis. Go Artemis.
That was a fun interview, and again, just so neat to see all the people who are here. I mean, still hours before liftoff. Not even hours before liftoff, but hours before a 2-hour launch window. So people just really committed to being here and seeing it in person.
Yeah, you can see the Banana Creek is already buzzing.
Yeah.
There behind Leah. You could hear the chatter in the background. It's an exciting time.
Yeah, you could tell that it's a lot louder than we noticed because we just have very good mics, but you know, she's obviously yelling over a huge crowd there. So super fun, super exciting, and yes, I hope that we all get to see liftoff here shortly. Okay, so as we know, Victor, Reed, Christina, and Jeremy will have their hands full during their mission. So for some of their test flight objectives, let's go back to Megan Carter at the moon board.
All right, as we have seen from those camera views, their capsule is very compact, obviously. So let me show you a few cool things about this piece. The Orion capsule is going to only be about 16.8 feet in diameter and a whopping 10.5 in height. Think of it about the same cubic feet as 2 minivans. So obviously every piece of that capsule has been planned with purpose. And a really great example of that is going to be these seats that we have seen that live view of. Now these seats are going to be out for launch, re-entry, and splashdown, but in between they are stored in between to give them more room for daily activities and things like that. While they are on board, obviously they are going to have a lot of things to do. One of those is going to be to manually fly Orion, as we've discussed, but they also have several other objectives as well. And they are going to be doing lots of system checkouts, checking out the service module, making sure everything is working correctly. They're also, like I said, going to have a chance to manually fly. Now this was taken during one of their training simulations, but as you can see here, they will have advanced flight displays, hand controllers, touchscreen interfaces, so much to work with and practice with as well. Now, while on board, they will also have the ability to eat those shelf-stable meals that are designed specifically for microgravity. I think I saw somewhere that one of their meals is going to be mac and cheese and brisket, so that makes the Southern in me very happy. All right, but they are going to have also some time to look at some things like power and propulsion. They will have 3 key propulsion systems that are going to help power Orion as well. And speaking of power, I want to bring you back to the service module real quick because I wanted to point out these 4 solar panels. These are going to take about 18 minutes to unfold like giant wings, and they're going to stretch 62 feet from end to end, and these are going to help power the service module and in turn provide what the crew needs for their journey. So as you can see, spacecraft is built specifically for what we need and to guide them and get them home safely. All right, back over to you, Megan.
Thank you so much, Megan. You know, it's taken thousands of people, many years to get to us to where we are today. Let's meet some of the people of Artemis who've made this flight test possible.
I am the Artemis Launch Director.
I'm the Orion Crew Survival System Manager.
I'm the Artemis II Chief Training Officer.
I'm the SLS Launch Integration and Mission Operations Lead.
I am the Recovery Director.
And I'm Boeing's Core Stage IPT Leader at Kennedy Space Center.
I am the Artemis II Entry Flight Director.
And I'm the Closeout Crew Lead for Artemis II.
Our job is to design the spacesuits that the crew will wear for the Artemis II mission. The team here at Johnson Space Center in the Orion Crew Survival Systems Lab does pretty much everything involved with processing the suits, designing the suits, qualifying the suits, testing them for the Orion mission.
The role of the Chief Training Officer is to manage both the planning and the development of how we are going to train our astronauts and run our simulations for our flight control team for the mission, and then go implement that plan.
Recovery team is responsible for 3 things. So recovery is what we call our nominal recovery situation, where we go recover the crew and the capsule at their designated landing site. Rescue is in case we do need to rescue the crew or they landed somewhere else that we did not plan. And then the retrieval is us getting the capsule if they did land somewhere where we did not expect them to.
My job on SLS is to manage the operations architecture on the SLS program. One of the specific things that we do is support launch operations. It means a lot to be a part of this Artemis team, to show the next generation in seeing what may come.
I am responsible for our core stage processing at Kennedy Space Center. My team is responsible for that core stage, and it's our responsibility to make sure that core stage is safe, built correctly, and there's going to be 4 of our astronauts, and it's going to get them to their ride around the moon.
I've been a flight director for over 10 years now. I worked on the Artemis I mission, and after that mission completed, I was assigned as the entry flight director for Artemis II. I can't wait to see the hatch open after splashdown. That's when we know that our mission will be complete and the crew will have safely returned to the moon and back to Earth.
Closeout Crew is responsible for getting the astronauts up to the white room, getting their helmets and gloves on, getting them into the vehicle safely, connecting all their umbilicals, making sure they're ready to go for launch, and then closing the crew module hatch. The reason we do this is to expand mankind's knowledge. If I can be a part of that, doing anything, I want to do that.
The launch director role really is to step back and kind of take that big picture view of launch. How are we doing on any NCs? How are we doing on our timelines, our procedures? Artemis II is a beginning. It's going to inspire a new generation. It's going to uncover science. It's going to serve as a pathway to places that we have never been before.
And to meet more people of Artemis, you can head to the link we're going to put up on your screen there. Just, again, really nice to see all the faces that have put in the work, the time, the hours, the dedication to get us to today.
Yeah, so many professionals that worked so hard on this mission.
And what was really fun to see is, you know, we interviewed Taylor Hose, closeout crew lead, as he said, and that's who we are now seeing inside of the White Room as they are getting ready to close out Orion and close one of two hatches. We have the side hatch of the crew module as well as the launch abort system hatch, correct?
Yeah, the astronauts are in the capsule. They're ready to go, and now the White Room is very busy as they're getting ready to close both of those hatches. That's a great shot right there where you can see them. Almost looks like they're doing that hatch seal inspection that we talked about.
And so, Nicole, as we continue to see them get ready to close that smaller hatch, again, the crew module side hatch, let's take some questions now.
Sounds good.
A lot has changed since Apollo, and I have a few questions about what's next. What part of the moon are we exploring through Artemis, and what are some of the key points that NASA needs to consider when planning missions like this?
Were you expecting to see Scarlett Johansson? I think that took you.
Yeah, I mean,
took you aback.
We've talked about this, but everybody has an interest in this mission. You know, it's humanity trying to explore and go back to the moon, and I love this question. You know, what part of the moon are we going to? You know, eventually we want to get to the polar regions, the South Pole specifically. We think that there are volatiles there, so water ice, something that can be harnessed as a resource as we create the permanent base on the moon and then try to get onto Mars. But getting to the moon is a tricky mission. You know, we're going further than we have in a long time, and you know, on the International Space Station we're 250 miles from the Earth, and so we're pretty close. We resupply that spacecraft pretty often with cargo missions, but the further and further you get away from Earth, the more you have to think about the lack of cargo, the comm delay. You know, there's a communication delay the further away you get, and so there are different and unique problems as we continue to explore further and further out into the solar system.
And there is so much to learn about the moon, so it's no surprise that yes, even though our goal is to have a moon base at the lunar South Pole, the lunar South Pole is not the main focus of this lunar flyby. So instead, the crew is going to be focused on observing the far side of the moon. So this is actually an animation of what teams expect the moon to look like if the crew launches today. So this is, of course, the side that faces the moon, and this is the far side of the moon, which when, again, the crew does their lunar flyby on flight day 6, we are expecting this will be their view. What an amazing view and an opportunity.
Yeah, you know, there's so much to learn from this particular mission, because obviously we're not landing with this mission, and so they actually potentially could see the South Pole and kind of scope out what our landing regions look like in the context of the entire moon. But also they're going to see parts of the lunar surface that have never been seen before by the human eye, and so they're going to take these detailed notes. They're going to record themselves talking about what they see. You know, we do a ton of geology training as astronauts, especially this Artemis II crew. They did a ton of geology training working with scientists to learn how to pick out the unique portions that we want to go study. You know, what is the context of the moon? What parts of the moon look interesting and look different? You know, the impact craters that we talked about earlier. So really trying to take all the pictures, take all the observations, write down, talk about their observations, and record as much data as we possibly can for the researchers back here on Earth.
Yeah, it's so important to, yes, we're all talking about what they hope to do during this 10-day mission, but you really do have to think about all the training that goes into this. I mean, you have 4 crew members who won't, you know, have the support the way that they've been having this. I mean, they'll be talking through communications, but you know what I mean? It's just them and the moon, right? So they need to be fully aware and equipped with everything that they'll need to do to be able to accomplish the objectives that we hope to accomplish during this mission.
Right, and their specific flyby around the moon, you know, the lighting will be different and the path will be different depending on when we launch. If we launch today, it would be different from tomorrow. And so, you know, they actually had to learn the geography of the moon so that they can orient themselves when they're on the backside of the moon, because they're not going to have communication. You know, they're going to have a, I think, 45+ minute comm blackout while they're, while they're on the far side of the moon. And so they themselves have to know what things look like on the moon, how to orient themselves, and how to get the data that we're looking for.
Yeah, really ambitious mission. Excited to be here at the start of it. All right, so another check of the clock, 2 hours, 57 minutes and counting to the opening of our 2-hour launch window for Artemis II. This pivotal test flight comes 250 years after America began its journey as a nation. As we celebrate that milestone, a special live performance now of our national anthem by singer Ann Wilson. crew has the opportunity to set the ambiance, if you will. They were given the opportunity to adjust the lighting as they see fit, again, just so that they can get comfortable. It's kind of like when we are on a plane and you get the opportunity to...
Sure, yeah, you don't want the bright lights in your eyes. Also, you want to be able to see the screens well, or see the, the tablet on Jeremy's knee well, so they're going to adjust the lighting to what makes sense for the mission.
And we saw in that very quick shot there, our best camera view of the two hatches is actually that drag-on camera, like we were saying, that kind of moves around. So sometimes it's hard to show that. So there you have it. You can see that the closeout crew has closed the side hatch. And so right now, that's a panel that they have to close out in order to then close the next hatch, which is the launch abort system hatch. And so, Nicole, can you just quickly, again, talk to people about the two hatches, again, crew module first, and then the launch abort system hatch?
Yeah, so the crew module hatch is the one they're working on right now. They just got closed. You can see he's torquing those bolts down. And that is the hatch that completes the Orion capsule. And then you have the launch abort system, which actually is kind of almost a shell that goes around the capsule and holds onto the capsule during launch. And it has its own separate engines that can pull the capsule away from the rocket safely in the case of an off-nominal data point. So it's actually looking at roll rates and attitude and thrust and all sorts of different data in order to make sure the launch is safe. And if it's not, then the launch abort system will pull the crew module away and get them into a splashdown zone safely.
And as we wait for the crew to complete closing that side hatch of the crew module, let's head over back to Banana Creek, where we have Leah Martin standing by with the person who designed this mission's zero gravity indicator, named RISE. It was second grader Lucas Yee from California. Hey, Leah.
Hey, Megan. Yes, of the many special guests we have with us today, I think one of our most exciting guests is Lucas, who's joining us, like you said, all the way from California. He and his family actually worked this as a group project to design the zero gravity indicator. Lucas, can you tell us a little bit about your design?
Yeah.
So you named him RISE. Can you tell me why you picked that name?
It was very remote, representing the Artemis II launch and Earthrise. And yeah, that's pretty much it.
So were you really excited to find out that you won the competition and that your zero gravity indicator would be going to space?
Yeah.
So how does it feel? We're actually just across the river right now from Artemis. We can see it from where we're standing. How does it feel to know that design you created is actually currently on that rocket, just a couple hours away from going to space?
Really, 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 really surprised and very happy.
Now, Mom, you were telling me on the way over here that it was kind of hitting you what was happening. Tell me a little bit about that.
It's definitely very surreal to be here in person. It's definitely very surreal to be here in person. That Commander Weissman said that it's for all and by all. That we couldn't have said it better. We're just very grateful to be here. Super, super excited.
And we're so excited to have you here too. Now, Oliver, this is your first launch too. Is that right?
Yeah, that's right.
And how does it feel to be here just a little bit away from watching the first group of astronauts in your lifetime on their way to the moon?
It feels like very, very happy and surprised.
So if you had one word of encouragement or something to say to the crew who's sitting on that rocket right now, what would you say?
What?
Go Artemis.
Go Artemis.
Go Artemis. Thanks so much, Megan.
I would say...
And so the Artemis II crew, again, ZGI, zero gravity indicator. It's a plushie, a soft toy that is brought in to the spacecraft with astronauts so that it can be a visual indicator for when we have reached the weightlessness of space, right?
Yeah, you saw a little replica there that Lucas had, and then in some of the views in the cabin view, you could see it swinging and hanging earlier. So I think actually Jenny was the one who installed it into the capsule.
Oh, really?
Yesterday, yeah. So.
Oh, we have to unpack a lot here. We got to talk about Jenny, who we will get to here in a second. But then, yes, we will also go back into the capsule so that we can show you where the ZGI is now. But the ZGI was chosen by the crew after a contest where the crew asked for submissions. They got submissions from around the world to, again, design their ZGI that is going with them to the moon.
It's kind of like any other road trip. You need clothes, food, a map, your favorite toy. Really. Except this toy has a job to do up there because this is a zero gravity indicator. While not a scientific instrument, this safe and soft object tells the strapped-in astronauts that they've reached weightlessness. For Artemis II, the crew wanted a one-of-a-kind ZGI, so we asked you to come up with it.
Thanks everyone for sending in your entries from around the world. Over 2,600 of you submitted.
And we loved seeing all of your contributions. It was a really difficult decision because each design had a unique quality that stood out to our crew.
In the end, we were able to narrow it down to a top 5 from Finland, Canada, Peru, and 2 from the United States, Kansas and California.
In the end, we went with one called Rise. It was a design inspired by the Earthrise photo taken on Apollo 8, which is very special to our crew.
With the winner chosen, next came the task of bringing it to life here in the Thermal Blanket Lab at NASA's Goddard Space Flight Center. This lab specializes in custom materials to protect sensitive spacecraft equipment and is perfect for creating a ZGI that meets the rigorous safety standards of NASA.
Because you have to be concerned with whether the thread's going to outgas or if it will hold up, if it's flame retardant.
This is the Rise ZGI doll. All I have left to do is to close the opening here and hand sew the hat on, make sure its stuffing is stuffed in there, and we have our pocket here for the SD card.
And on that tiny SD card will be millions of names submitted to virtually join the crew aboard Orion.
Got Rise. Not the real one, obviously, but this is a replica. I mean, so clever for Lucas and his family to design.
Yeah, I love that he replicated the famous picture that we all love of Earthrise, and then I love that the bill represents the space in between the moon and Earth. It's just such a cute and wonderful way to represent this mission.
Yeah, and again, Earthrise, very important to this crew. It harkens back to the picture that was taken by the Apollo 8 crew where they saw Earthrise, and so very appropriate since, again, now here we are going to see Earthrise again with this mission.
Yep.
So yeah, so this is little Rise here. And then you heard in that video that there is an SD card that is zipped inside with the real ZGI with the crew. So get this, more than 5 million people submitted their names as part of NASA's Send Your Name to Space campaign. And actually, Christina said that her niece and nephew's names are inside that SD card.
How cool is that? Her nieces and nephews are going to go with her.
Yeah. Love this. Love that people are engaging in such a cool way. And actually, if we take a look back inside of Orion, we can actually see the actual ZGI inside with the crew. As we said, the purpose of a zero gravity indicator is to show when we've reached the weightlessness of space. Now, I know that it's probably dark in there because, as we said, the crew decided to just dim it a little bit for them. But here again, as we see, Reed on your left, Victor on your right. Below Victor, or next to Victor, again, because they're on their back, it's a little weird. It's a little hard to explain their orientation. But between basically Victor and Christina is where Jenny Gibbons has placed the zero gravity indicator. And Jenny, who, again, Nicole just brought up, Jenny is one of the backup crew members. So we mentioned how Andre is the backup crew member for the NASA astronauts. Jenny is the backup crew member for Jeremy.
Yeah, Jenny's one of our Canadian astronauts, and yeah, so she's been also helping with preparations for today and helping get the White Room ready, get the capsule ready, and she's actually going to be a Capcom for Artemis II as well.
Yeah, she's from Calgary, Alberta, completed astronaut training in 2020, mechanical engineer, combustion scientist, and actually before becoming an astronaut, she was an assistant professor. So again, another very well-accomplished person on the team. And I know the Artemis II crew has really enjoyed working alongside both Andre and Jenny.
Yeah, actually Jenny was our EBQ mentor when I went through our Ascent initial training, so she helped us with all of our spacewalk training, which was kind of cool as well.
Okay, and there we have Andre again, number 2, with the rest of the closeout crew team there. Why don't we get another check with Daryl and see how the launch countdown is going.
Still going quite smoothly here from firing room 1 here at the Kennedy Space Center. Launch team working no major constraints to launch, which is great news. We did get an update on a weather balloon that the launch weather officer and his team released. This is an important weather balloon released right around the 3-hour mark. And what it told us is that winds are around 10 to 11 knots in the upper parts of the atmosphere. That's important information for the launch abort system. Should the astronauts need the LAS, this would, of course, pull the Orion spacecraft off the top of the rocket in case there were an emergency, and then take them offshore to a water landing in the Atlantic Ocean. And so the winds are pushing onshore. And because they're pushing onshore, the launch weather officer is keeping a close eye on the strength of those winds, because if the Orion were to come off the top, and it's powered by 3 rocket motors which can propel it or pull it especially fast off the top of the rocket, it would go up into the air thousands of feet and then splash down in the water. And if you've got wind pushing against it, you don't want that spacecraft to come back and land on land. So they're watching that very closely because of the onshore flow. That onshore flow is also what's giving us a little weather action down to the south of us along what's called the beach line, 528. We got a whole lot of people out there getting ready to watch the Artemis II historic launch. Well, they just got a good soaking. Line of storms, line of rain showers, I should say, passed through that area and soaked the place. Certainly rain is a possibility, spotty showers from time to time, but overall the launch weather officer tells us that we are trending towards getting that stuff to all push to the west the closer we get to our launch window. A reminder, that window is from 6:24 p.m. to 8:24 p.m. Eastern Time. We don't have a specific T0 at this moment. There's a lot that needs to be calculated before we get there. We also need to get through the rest of the countdown on time. As of right now, we are right on time. The launch countdown is going exactly as planned. That's not something that we saw certainly in Artemis 1. There was a lot of flexing in the timeline during those 3 launch attempts back in 2022. But so far today, on our first launch attempt, we're really enjoying some really solid countdown work, some solid operations by the launch team so far. And to quote our friend Lucas, who created Earthrise, we all really like that. We'll send it back to the host desk.
Thanks so much, Daryl. Yes, we really like that, and we really like Rise and Lucas. So thank you for that. That was really cute. Okay, so again, here we are in the big box here. We have our full view of the rocket, looking glorious on there with, again, some clouds, but still weather is good for launch today. And then we have the closeout team continuing to do work in the White Room. We got confirmation that they have successfully completed pressurizing the counterbalance pressurization. Basically, as Daryl explained it before, the side hatch for the crew module is very heavy. So in order to open it, there needs to be pressure applied to it, and that's what we just completed, right?
Right, that's exactly it. So the CBA, that counterbalance assembly that we're talking about, has to be pressurized. It's a pneumatic system to help. So in the case of an egress, you know, Christina's the one that has to open that hatch. So once she gets it unlatched and unlocked, then that pneumatic system will help move the hatch. It weighs a lot, and so the average human cannot open that hatch by themselves. And so that's why we want to make sure that the system is pressurized, that it's not going to leak, and that it is ready to go in case they need to open the hatch.
So that is complete, and now what is happening are the seal leak checks. So that is in progress. Again, 2 seals go through the entirety of the hatch, and we will take the seals to pressure, hold it for about a minute, and just make sure that it is holding pressure. Again, we want to make sure that the crew has a safe, pressurized environment in any sort of situation while they're in Orion.
Yep, that's right. So we're going to take a look at it. We're going to take a look at the starting pressure, and then after a certain amount of time, we'll take a look at the ending pressure, and then there are certain tolerances that we will accept for flight.
2 hours, 37 minutes and counting from the opening of our 2-hour launch window today at 6:24 p.m. Eastern Time. After liftoff, it takes less than 10 minutes to reach Earth's orbit. Let's learn more about today's Ascent profile with Gary in Mission Control.
Hey, Megan. We are monitoring here in Mission Control Houston. Flight controllers are looking at data from integrity in the Space Launch System during the countdown. We're looking at some of the events happening in the White Room now and just making sure that all criteria is met to commit to launch and Ascent today. It's the team you see in this room that would be looking after Ascent, which is a very dynamic phase of flight. And after solid rocket booster ignition of the Space Launch System, it's this team that takes over control of the mission. There are voices you'll hear upon ascent, calls being relayed between Stan Love, the Capcom you see here in this shot in Mission Control Houston, that's the voice from this room, and the Artemis II crew on a communications channel aptly named Orion to Earth. Here are the calls you may hear during this part of the mission. Capcom Stan Love, his first call after responding to the crew's successful roll pitch maneuver at 30 seconds is AMT high. This notes that should we lose just one of the main engines, an alternate mission in low Earth orbit can still be achieved. At 1 minute 25 seconds, you'll hear max Q on PDL. This notes that reaching the moment of maximum dynamic pressure on the spacecraft. This event happens to be in line with a communication switch to another ground station, the Ponce de Leon Inlet Tracking Annex, located about 35 miles north of Kennedy. At 2 minutes 45 seconds, you'll hear SM primed, upper stage RCS ready. This means that the European Service Module propulsion system that's prepared for the next phase of aborts after the launch abort system jettisons, and the reaction control thrusters on the inner rim cryogenic propulsion stage that enable pointing and maneuvering are ready. At 3 minutes 50 seconds, you'll hear voice check on TDRS at the Kármán line. At this point, the launch abort system has jettisoned and revealed the Orion capsule underneath. This check verifies that the now exposed Orion antennas have a good signal over the tracking and data relay annex, tracking and data relay satellites which is part of a geosynchronous satellite network and the same assets that are used aboard the International Space Station. This communication switch happens to be at the Kármán line, a widely recognized boundary about 62 miles, statute miles, or 100 kilometers above the Earth's surface, where the air is too thin for conventional aircraft to fly and marks the point where our astronauts leave Earth and enter space. At 5 minutes 16 seconds, you'll hear the call 3-engine press. This notes that if one of the 4 main engines on the SLS core stage were to fail, 3 engines can carry the crew to a nominal main engine cutoff and proceed with the expected mission timeline. This is an important call that gives more assurance of continuing today's moon mission. At 7 minutes, you'll hear expect nominal shutdown. You'll hear this call should the main engine performance be as expected up to this point. Shutdown plans can vary and may impact G-forces experienced by the crew or future burn plans, but a nominal shutdown is more indicative of continuing the mission on the expected timeline. At 7 minutes 30 seconds, you'll hear AOA open. This notes crossing into a new abort profile. At this point, an abort would use Orion engines to escape the core stage, and the altitude and velocity are enough to make it 1 lap around the Earth and aim for a splashdown in the Pacific Ocean instead of the Atlantic. And then, of course, shortly after 8 minutes, you'll hear nominal MECO. You won't hear MECO right away. Teams here wait until the core stage has separated and the trajectory is confirmed as expected before that call to the crew. Now, this Ascent profile is approximate, as there may be calls that move a few seconds depending on the trajectory, and of course these are the calls and times for a nominal trajectory. Teams in this room have been training extensively to prepare for any and all scenarios, and they are confident and ready to take this crew into space today. In today's pre-brief, the flight director Judd Friedling expressed his confidence to the team, citing the hundreds of simulations to prepare for this very moment. These are the calls you'll hear during Ascent less than 3 hours from now, but now we'll turn our attention to the countdown to launch and send it back to you, Megan, at the Space Coast.
Thanks so much, Gary. Now, one of today's 4 astronauts, of course, Canadian Space Agency astronaut Jeremy Hansen. Let's go now to Jasmine with her next guest.
So much, Megan. Yeah, we're joining you live now from the Operations Support Building here at Kennedy, where crowds are starting to gather, and we're honored to have Lisa Campbell of the Canadian Space Agency joining us. Lisa, Jeremy Hansen is about to make history as the first Canadian to venture to the moon. What does that milestone mean for your agency?
Thanks so much, Jasmine. It's wonderful to be here. It's such a special moment, both for our astronaut colleague Jeremy Hansen, but also for Canada. We're here because of decades of public investment in space robotics, in space collaboration, and so for our country, we're very proud. He's so ready. He's been waiting for this his whole life, preparing, training, and he's a wonderful example of Canada.
Yeah, and that's a perfect way to capture Jeremy. He really has been prepping for this his whole life. This will be his first space flight. So what has it been like watching him become part of this Artemis II crew?
Well, as I mentioned to you, I've known Jeremy since 2020, and he's a colonel, a fighter pilot, a father, and he really is a very dedicated, passionate human being. So both for him to realize this goal of being an astronaut and flying, he also is hopeful that witnessing that will raise awareness about the value of a space program, of the benefits here on Earth, of exploring the universe and our place in it.
Wow, that's beautifully said. And really, this international collaboration has been going on for quite some time now. We've worked together in low Earth orbit and now going into deep space together. So why is it so important that we have these international partnerships?
It makes us stronger. We can go faster and further together. Canada is one of the original signatories of the Artemis Accords, and Canada and the United States have been partnered for more than 60 years in space.
Wow, that is phenomenal, Lisa. And this really is a team effort in many ways. We also have Jenny Gibbons. She'll be listening in on Capcom. What is her role going to be like?
So Dr. Jenny Gibbons has been training all along as the Canadian backup with the Prime crew. Last night, she was in the Orion capsule checking out all of the communications, making sure all of the systems test out and work perfectly. And then she will be among the first Lunar Capcom, helping the astronauts navigate during their mission.
Wow, Lisa, that is so exciting. Any final words for the nation of Canada before today's mission?
Just, we are so proud, so excited, and we can't wait to welcome Jeremy home.
Fantastic. Lisa Campbell, thank you so much for being here today.
Thank you, Jasmine.
Of course. And with that, let's get back to NASA's Megan Cruz.
And right now,
go ahead. Ma'am, TBA press has been completed. Did you see any drop in pressure? And MS1, we saw just a little bit. It is just over 2,600 now. Copy. Thank you, ma'am.
again, a call out to mission specialist Christina Cook. Again, it was her responsibility to monitor the pressure on the counterbalance system that will help open the side hatch. And she did report a drop in pressure, but it seems like it's within nominal limits.
Right. They might have had a small drop, but you know, we have a starting pressure and an ending pressure, and as long as the difference isn't too high, then we will take that, and the engineers know exactly what they're looking at for in terms of that delta pressure.
And so again, that milestone on the checklist of things that have to happen before they launch today, that is complete. The crew, again, still inside comfortably as the closeout crew team work to close the side hatch. Again, a separate seal leak check, followed by a full cabin leak check, and then they will close the last abort system hatch.
lots to do still in the White Room and marching down the countdown timeline well.
And so Bill, again, number 3 there, he is holding a silver flex hose. That hose is what will be connected to Orion in order to do that cabin leak check. So again, it does seem like we continue to march down through the milestones in this countdown. Hopefully lifting off today within our 2-hour launch window that opens at 6:24 p.m. Now, right now, people inside the Kennedy Space Center Visitors Complex are learning about this mission. There are great exhibits there about the rocket and Orion, and of course, our Megan Carter with the moon board.
All right, Megan and Nicole, yeah, you mentioned that checklist before launch. That checklist is going to continue during the mission, as well as there are several vital objectives that we are hoping to accomplish with this mission. So we've talked about the rocket. We've talked a little bit about Orion. Obviously, during Artemis I, we had that test flight, and there were no humans on board. That is our one big difference for this one, and we are going to have that crew this time. So what are they going to be up to during this mission? Let me tell you just a little bit. Now, for Artemis I, like I mentioned, we were really focused on the SLS, making sure it had the power and capabilities that we needed. We were also checking out the Orion spacecraft in deep space environments, making sure that it was good to go. Now for Artemis II, we are going to be taking the testing for Orion to the next level by adding that human component. So those test objectives are going to start even before launch. Like you mentioned, they are out there making their way through that checklist. But these objectives are going to start now, and that includes safety. So one really great example of safety is going to be something called the egress baskets. They're out there in the spacecraft, obviously, and should a situation happen to come up, they are going to have something called the egress baskets they can get in, and those are going to zip line them essentially down to the ground within seconds to safety. Another great example of those safety procedures are going to be the LAS, or the Launch Abort System that I mentioned earlier. Just a reminder, that's the one that can pull the crew and capsule away from any danger within a few minutes of into the launch. Now, those are just a couple quick examples, but our recovery teams